Ever wondered how Spotify suggests songs that you might like, or how your email filters spam? That's machine learning in action. Now you might be thinking, what is machine learning? Well, it's a field of computer science that enables computers to learn, grow, and evolve without the need for explicit programming. It's like teaching a child to recognize different shapes. You don't program the child's brain. Instead, you show them various shapes, and they learn to identify them over time. Similarly, machine learning algorithms learn from data. They find patterns, make predictions, and improve their predictions over time. So whether it's your music app knowing your taste in music, your email app filtering out junk, or your GPS predicting traffic, it's all powered by machine learning. So in essence, machine learning is all about teaching computers to learn from data and make decisions or predictions based on that. Imagine teaching a child to identify different animals. You show them pictures of animals and tell them the names. This is how supervised learning works in machine learning. Supervised learning is a type of machine learning where the machine is trained using labeled data. This means that the input data, such as the animal pictures, is paired with the correct output, or the animal names. Let's dive a little deeper into this concept. Supervised learning is like having a supervisor or teacher present during the learning process. The machine is provided with a set of examples or training data, where the correct answer or label is already known. For instance, you might have a data set of animal images where each image is tagged with the correct animal name. The machine analyzes this training data, learning the patterns and relationships between the input and the output. It's like when a child sees a picture of a dog and hears you say the word dog. Over time, the child learns to associate the image of the dog with the word dog. Once the machine has been trained on this labeled data, it can then make predictions on new, unlabeled data. Going back to our animal example, this would be like showing the child a picture of an animal they've never seen before, like a platypus. Because the child has learned what different animals look like, they can make an educated guess that the platypus is an animal, even if they don't know its exact name. Now you may be wondering, where is supervised learning used? Well, it's often used for tasks such as classification, regression, and object detection. Classification is about predicting a label, and regression is about predicting a quantity. For example, we might use classification to predict whether an email is spam or not spam. On the other hand, we might use regression to predict the house prices based on various factors like location, size, and age of the house. Object detection, another popular use of supervised learning, involves identifying objects within images or video. For example, this could be used in self-driving cars to identify other vehicles, pedestrians, and obstacles on the road. To summarize, supervised learning involves training a machine on labeled data, where the correct output is already known. The machine learns to predict the output for new unlabeled data by understanding the relationships in the training data. It's like teaching a child to identify different animals by showing them pictures and telling them the names. So just like a child learns to identify animals by looking at labeled pictures, a machine learns to make predictions from labeled data. And that, in a nutshell, is the concept of supervised learning in machine learning. Now imagine a child playing with a box of Lego. They figure out how to build structures without any specific instructions. This is similar to how unsupervised learning works in machine learning. Unsupervised learning, as the name suggests, is like learning without a teacher. Just as the child playing with Lego, the machine is given a set of data. But unlike supervised learning, this data is unlabeled. This means the machine doesn't have the luxury of knowing the correct answer or output ahead of time. Instead, it needs to figure out the underlying patterns and relationships within the data all by itself. Think of it as a detective at a crime scene, sifting through clues to piece together what happened. The machine must act as its own detective, analyzing the data and drawing conclusions about the information it has been given. Let's stick with our Lego analogy. Suppose the child has a box filled with different types of Lego blocks. Without any instructions, they start to sort these blocks based on their own criteria. Maybe they group them by color, or by size, or by shape. This is similar to a process in unsupervised learning called clustering, where the machine groups the data into different clusters based on shared characteristics or similarities. Another task that unsupervised learning excels at is dimensionality reduction. This is a fancy term that essentially means simplifying the data. Imagine our Lego-loving child has built a complex structure, but they want to understand its basic form. They might start removing unnecessary blocks until they're left with the core structure. Similarly, a machine might simplify complex data by identifying the key features that capture the most important information. Unsupervised learning also shines in anomaly detection. Imagine you're the child playing with Lego again. You've sorted all your blocks by color, but suddenly, you find a block that's a completely different color than the rest. It's an anomaly. It stands out. In the same way, a machine can identify unusual data points that deviate from the norm. Unsupervised learning can seem a bit daunting due to its lack of clear instructions. But it's this very characteristic that makes it so versatile and powerful. It allows machines to make sense of complex, unstructured data and uncover hidden patterns that we might not even be aware of. This type of learning is crucial in areas where we don't have all the answers. It's used extensively in exploratory data analysis, where we're trying to make sense of new, uncharted data. It's also used in scenarios where we're dealing with vast amounts of data and need to simplify it or find anomalies. Unsupervised learning is a powerful tool in the machine learning toolbox. It's the equivalent of giving a child a box of Lego and letting their imagination run wild. The possibilities are endless, and the results can be surprising and insightful. Just like a child learns to build structures with Lego without any specific instructions, a machine learns to find patterns in data without any specific output in mind. Now that we've delved into the world of machine learning, let's recap the main points. Machine learning, an exciting field of computer science, empowers computers to learn without requiring explicit programming. It's like giving a brain to our machines, allowing them to learn from experience and make decisions just like humans. We explored two main types of machine learning: supervised and unsupervised learning. Supervised learning is akin to a student learning under the guidance of a teacher. Here, machines are trained on labeled data, where each piece of data comes paired with the correct answer or classification. This training enables the machine to learn the relationship between the input and the desired output, and then predict the output for new, unseen data. It's widely used in tasks such as classification, regression, and object detection. We illustrated this concept with our fruit basket example. The machine learned to identify different fruits based on their shape, color, and texture. Once trained, it was capable of correctly classifying a new, unlabeled fruit. On the other hand, unsupervised learning is similar to a child learning to understand the world around them through exploration and observation. Here, the machine isn't provided with any labeled data. Instead, it learns to find patterns and relationships in the data on its own. This type of learning is commonly used for tasks such as clustering, dimensionality reduction, and anomaly detection. In essence, the key difference between supervised and unsupervised learning lies in the presence or absence of labeled data. Supervised learning uses labeled data for training, while unsupervised learning does not. So, whether it's suggesting your next favorite song or filtering out spam, machine learning is hard at work making our lives easier. And remember, it all starts with teaching a machine to learn, just like teaching a child.